In OpenStax Calculus Volume 2, we are working in Section 3-4 on partial fractions, and I'm kind of taking this slow and easy to make sure everybody understands the different types of problems and how to break them up. So in this particular problem, since our top power is higher than our bottom power, then see it says the degree of p of x is greater than or equal to the degree of q of x, which is what we're talking about. Then we're going to use long division for this, okay? But a lot of you probably haven't done long division in a while. So I'm going to move over here to the side and say x plus 1 is the bottom. We're going to divide that into x squared plus 3x plus 5. And I'm literally going to break this up into tiny little bits. You always start out with your first term. X squared over x is just x. So that's what goes up here. Then for down here, we do that x that we just got times x plus 1, which is here, and distribute, and we get x squared plus 1x. But when we're going to subtract that, it means we have to subtract both pieces. So x squared minus x squared is 0. 3x minus x is 2x. You bring down your plus 5. Now, your first term here, and your first term here, 2x over x is 2. So I'm going to put a positive 2 here. Then I'm going to multiply that 2 by my x plus 1 and get 2x plus 2. And when I subtract, as you do in division, then this is gone, and 5 minus 2 is 3. 3 over x does not divide. This is my remainder. So this problem is rewritten as the integral of x plus 2 plus 3 over x plus 1 dx. And now we actually have a problem that's pretty simple, because if I break this up using the sum and difference, then I have the integral of x dx plus 2 integral dx plus 3 integral of dx over x plus 1. Well, x dx is just x squared over 2. 2 integral dx just gives me 2x. Here, u is x plus 1, du is dx. So we have 3 ln x plus 1 plus c. And that's it for that one. That's not bad at all. The long division, just go back through the steps, walk through it piece by piece, and make sure you know how to get there. Okay? Now, we are going to do non-repeated linear factors. That just means that the factors that you get on the bottom don't repeat. Later on, we're going to do one that does repeat. This is going to be very much like the first problem that we did, but it's got a different denominator to start with. It's just got a little extra on there. So the thing to remember is that when you have linear factors that do not repeat down here, then I just use constant numerators. If my linear factors do repeat, we have to look at that a little differently. So this problem is very similar to what we did at the beginning, except it has a GCF on the bottom that we didn't have. So we have 3x plus 2 over x minus 2, x plus 1 dx. So when I do my partial fraction decomposition, I'm going to have in this case a over x plus b over x minus 2 plus c over x plus 1. And when I try to put it all back together, then my a needs to multiply by x minus 2x plus 1. So let's look just at that piece for a second. This, when I FOIL, is x squared minus x minus 2, and then you distribute your a. So ax squared minus ax minus 2a. My b needs to multiply by x plus 1. So that's going to be bx squared plus bx. And my c is going to need to multiply by x minus 2. So I'm going to have plus cx squared minus 2cx. Okay? All right. Now we're going to break this up into my like terms. I have x squares, I have x's, and I have a constant. So I'm going to make 3 lists. Ax squared plus bx squared plus cx squared equals. There is no x squared in this numerator, so we put 0. Now for my a's, I have minus a plus b minus 2c equals 3 from my x's in my numerator. Constant, the only constant I have is a minus 2a equals 2 as the constant from my numerator here. Now, there's lots of ways to work this out. You just have to kind of take your time. We're going to start on the simple one here. A equals negative 1. So that means I can put right here negative 1 plus b plus c equals 0. And here I can put positive 1 because that's negative 1 plus b minus 2c equals 3. The easier of the two problems looks to me to be the first one. So I'm going to say b equals 1 because I added the 1 and then minus c. So 1 plus 1 minus c minus 2c equals 3. 1 and 1 is 2, minus c minus 2c is minus 3c equals 3. Subtract 2, so negative 3c equals 1. Divide, and c is negative 1/3. If c is negative 1/3, then b is 1 minus negative 1/3 or plus 1/3, which is 4/3. When I write this as my problem, using this as my template, I have the integral of a, which is negative 1, over x dx, plus the integral of b, which is 4/3. When you do this, I'm going to put, well, you know what? I think instead of what I was thinking, I'm going to put my 4/3 out front and just leave this as 1 over x minus 2 dx. Plus, c is negative 1/3, so let's go back and make that a minus, actually. Or maybe I just don't know what I'm doing. Sorry. Minus 1/3 integral of 1 over x plus 1 dx. So I could have put my 4/3 up top here and my negative 1/3 up top here, but I was just going to have to pull them out anyway, so let's go ahead and pull them out. It's done. All right. If this one is u equals x and du equals dx, then I have negative ln x. Plus, if u is x minus 2 and du is dx, I have 4/3 ln x minus 2. Minus, if u is x plus 1 and du is dx, I have 1/3 ln x plus 1 plus c. That's it, guys. That's how that one works. All right.